Okay, welcome back. So on your guided notes sheet, this was the last problem that I had selected to do with you in the guided notes, which is number 42. I'll read the directions. It says find the total area between the region and the x-axis. And our function is y equals, I'm just rewriting it, 3x squared minus 3. And the bounds are negative 2 is less than or equal to x, which is less than or equal to 2. So again, that's our function, and we want to find the total area between the region and the x-axis. So you always want to start off with a drawing. And remember, the recipe in your book tells you not only do you want to start off with a drawing, you want to determine where that function crosses the x-axis. You want to get those x-intercepts. Okay? If you're just going straight algebra, you're going to take your function, and remember that to get the x-intercepts just from college algebra, question mark, how do we do that? Remember, you have to let y equal 0. So you're basically going to take 3x squared minus 3 and set that equal to 0 and solve. Pull the GCF, which is 3. And you have a DOS, a difference of squares here. I always say with my college algebra students, can you recognize that that's a difference of squares? Okay, factor it. Curly brace two solutions, namely negative 1 and 1. Notice that negative 1 and 1 are where the x-intercepts occur. Okay, well that helps us visually, and I don't want to go too deeply into this. I just want to show you how to lay it out. I'm going to use some different colors here to really help you see it. So it helps us break up the bounds. So one integral is going to be from negative 2 to negative 1. Okay, I'm coloring that in purple. The other integral, let's see what color, dark green. The other integral is this one that lives here below the x-axis, and the bounds on that are going to be negative 1 to 1. And then this one I'll do in, say, brick orange here. The bounds on this last one, I try to use 3 different colors. Or the bounds on the last integral are going to be 1 to 2. So we could set up 3 different integrals, and I showed you how to use finite integral on the calculator. I don't want to full-blown go through the integrals right now, so I just want to talk about general structure. Since you're dealing with total area, and one of the pieces is under the x-axis, what you're going to have to perform is a maneuver, something like this. So we would integrate from negative 2 to negative 1 using, say, that finite integral option on our calculator, so of the function, plus the absolute value, because remember, of the integral from negative 1 to 1 of the function. And notice I'm throwing that in absolute values because that's the one that's below the x-axis. And then plus the integral from 1 to 2 of the function. And the function, of course, was 3x squared minus 3. Now, if you do that, I'm going to lead you to explore that on your calculator, but if you do that, one area is going to be 4. This here area is, if you just hit finite integral, negative 1 to 1 on the calculator, it's going to come out negative 4, but you know to throw that in absolute value now. And then this last integral is also going to come out as 4. So 4 plus 4 plus 4 makes 12. So the total area is 12 on that one. So at first we're just playing using that finite integral on our calculator, but we clearly know how to do it by hand as well if we had to. All right, hope that helps.